Now we're going to be looking at scatter plots. So they're graphs. We're going to be doing graphs, and they will be generally in quadrant 1. And we usually answer information based on those graphs. So interpolation and extrapolation, which we'll get to in the next chapter. But we need to just kind of understand some basic stuff. So the title of the graph tells others what is plotted on your graph. They're usually listed as y versus x. So it's good for us to label the axis here as, well, I'm just going to label this as y, because y is vertical, and then the horizontal is the x, that's down here. And y versus x, so the y is distance, so the title is y versus x, and so for us that would be distance versus, I didn't actually see that on the bottom there, so I'll write this down first. Distance versus, I'm assuming time. Yeah, time. And it might be good to write distance in and then put in brackets kilometers versus time, and then in this case it looks like it's in minutes, and then you can kind of underline or whatever. So that's what our title will be: distance versus time, kilometers versus minutes. The independent variable is the one that you need to know first. What in this case is the independent variable? Where do you find it on the graph? So the one that you need to know first is in this case time. And time, because you're going to need to say, for instance, we're going to say here, when time is 10 minutes, how far have we gone? So you want to, or when time is 20 minutes, how far have you gone? Whenever you travel somewhere, you look at, well, how long have you been driving for, and that tells you, usually, unless you know, like if you know your speed, that tells you how far you've gone. So you want to know the time first, and then that will dictate the distance you've traveled. So the independent variable is the thing that you need to know first, and that's always the x-axis. So the independent variable is going to be known as it's going to be whatever's on the x-axis, and in our case, that is time. And it's usually found, or it's always found, on the x-axis. So I'll write in here just independent variable. Now the dependent, that's the one that depends on whatever you choose. And so the dependent variable would be the y-axis. So how far have you gone? What is your distance? Well, that depends on how long I've been driving. So it's dependent. So the y-axis is our dependent variable. And for us here, that is distance. All right, it says determine what one square is worth on the x-axis. This is known as the scale. So let's look at the x-axis. I can see markings 10, 20, 30, but that's not what one square is worth. So what is every one of those squares worth? And so you can look it up. There's 1, 2, 3, there's 5 squares, and there's 10. Here's our label of 10. So 10 divided by 5 is 2. Does that work? Well, 2, 4, 6, 8, yeah, 10. So what is every square worth? Every square is worth 2. And that is our scale on the x-axis. Now we want to know is what is our scale on the y-axis. So I can see 2, 4, 6 on the y-axis, but those aren't every square. Every square looks like it's worth 1. 1, 2, 3, 4. So every square is worth 1. Notice that the squares don't have to be the same on the x and y-axis. So the scale for the x-axis is 2, and the scale for the y-axis is 1. It wants us to state the coordinates of point A. Well, I don't know which one here is point A, so I'm going to have to figure that one out first. Okay, so it looks like point A is right here. And so we need to find the coordinates of that. And so it looks to me that that is 10 and 8. So we're going to go 10 to the right and then 8 up. So 10 to the right and 8 up. 10 to the right and then 8 up. But what does that actually mean? Well, x comma y, those are our instructions, and our x is time, and our y is our distance. And you can look it up on the graph if you want. So what does that mean? Well, it means that after 10, is it 10 minutes or 10 seconds? I think it's minutes. After 10 minutes, we've gone 8, I believe it's kilometers. So that's what that means. Now it wants to know, state the coordinates of B. Okay, so let's go to B here. So B is right here, and that goes down, 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 and I'm right there. And that's kind of difficult to see. So 20, every one of these boxes is squares for 2. So 20, 22, 24, 26, 28. So I'm right in the middle. The middle between 24 and 26 is 25. Okay. And so this spot right here is 25. And then this goes all the way over, and it looks like I'm at 17. So I'm 25. I have to go 25 over to the right and then 17 up. Those are our instructions, 25 and 17. So I will write that down. Our coordinates are 25 and 17. What would that mean? Well, that would mean after 25 minutes, we've gone 17 kilometers. Now it says here, a trend is the pattern shown by the data on the graph. So we're looking to see, is there a pattern? State the trend of this graph. So you look at this graph, what is the trend? What is the pattern? Well, the trend is, looks like we're heading up. And what I mean by that is, as time is going on, our distance is going further. And that seems like that would be an accurate description. For instance, it takes me 30 minutes to get to work. So like the more time I drive, the further away I'm going from my house, the further distance I've traveled. That's not always going to be the case for depending on what this y-axis is. Sometimes it can be distance from home. So we'll do things like that. But the more time you spend driving, the further distance you're going to go. So what is the trend? So the trend would be, as time goes on, the distance traveled goes up. So as time goes on and on and on, the distance we traveled gets more and more and more and more and more. We get higher and higher and higher in terms of the distance that we've traveled. So that would be what the trend is. So we'll do another video for the next question.